Hello everyone, my name is Jitesh Mohanan, and today I am going to present you a video which shows the experiments that we have performed as a part of our study on the target guarding problem. This is in fact a supplement to our paper titled Towards Real-Time Autonomous Target Area Protection, Theory and Implementation. There are 4 authors for this paper, including myself. Apart from me, the other authors are Mr. Mani, Dr. Raghav and Dr. Bharat, who is our professor. We all are from the Indian Institute of Technology, Madras in India, and Mr. Mani is a PhD student at the Robotics Institute at the University of Michigan. This video is in fact a supplement to our journal paper, and that's why I will not be going into the detailed mathematics behind the entire experiment and the theory thereof. So interested viewers are advised to go through the paper with the above title. So this video is it will show you the experiments that we have performed to validate our results on the target guarding problem. So to give you a brief background on the target guarding problem, so as the name suggests, it's a problem of guarding a target, which is a very common scenario in defense and military establishments. So the problem here is to guard a target which in this work we have assumed to be stationary from a person called the evader. We will refer to him as E or the E robot. So the person who tries to save the target is called the pursuer or the P robot. So the P robot will try to secure the target from an attack by the E robot by intercepting the E robot as far away from the target as possible. Naturally, the E robot, if at all he is in a position to lose the game, would try to go as near to the target as possible, and the P robot would try to foil his attempts to secure the target. So that's the brief about the problem. Our paper has 2 main contributions. The first contribution is that there is already a COIP law, which is the optimal law for both the pursuer and the evader to secure the target when the target lies in the pursuer's dominance region. Our paper tries to make the COIP law implementable in real time. So the original COIP law was not amenable for seamless real-time implementation because of all the complex mathematics that is involved in the equations that are derived. Apart from this contribution, our paper also discusses what the evader or rather what the pursuer strategy would be if the target would lie in the evader's dominance region. The experiments that we are going to show in the video here demonstrates our remodified COIP law, which we have implemented as a lookup table on the pursuer robot. So we have a play area which has a stationary target, one pursuer robot and the evader robot. So we will now go ahead to explain the robots that we have used for the experiments and what are all the measurements that we have made and so on. Yeah. This picture that you see here before you shows the Lego robots that we have used for the experiment. This specific picture shows you the pursuer robot, which has been mounted with an ultrasonic sensor array So by the term ultrasonic sensor array, I mean multiple ultrasonic sensors mounted on the robot. Now, why do we need to use the ultrasonic sensors on the robot? Because we are claiming our modified COIP law to be implementable on autonomous systems, and therefore we want to remove the usage of global sensors like GPS or any sort of motion capture system. Therefore, we have mounted local sensors on the robot, and for this specific example, we are using ultrasonic sensors on the robot. So, of the array of ultrasonic sensors, we would be using two sensors at a given instant. So, two ultrasonic sensors would be active at any given instant on the pursuer robot. One would be to find the distance from the pursuer to the evader as the game progresses, and the other sensor would measure the distance from the pursuer to the target. This distance is measured automatically by the ultrasonic sensor, and the information is relayed to the CPU inside the robot. So this clip shows you the video grab of the actual experiment being performed. In a moment you can see both the pursuer and the evader robot starting to move. The pursuer robot is the one on your nearer side, and the evader robot is the one on your farther side. So you can see that the pursuer robot intercepts the evader robot in real time before the evader robot is able to get to the target. So as mentioned before, the only measurements that we are taking for the experiment here is the distance from the pursuer to the target and the distance from the pursuer to the evader. So both these distances are obtained by ultrasonic sensor array mounted on the pursuer robot, out of which one of the ultrasonic sensor, which is directed towards the target, you can actually see the sensor rotating on the pursuer robot. This clip shows the pursuer robot in action under closer focus. So you can see the ultrasonic sensor mounted on the robot moving so that it's always directed towards the target in order to make the distance measurement as accurate as possible. That was all with respect to the video. Thank you everyone.